Hey all, I just wanted to talk about our next step, which to my video on here. Hi, nice to see you. Um, that introduces hypothesis testing. This is a challenging topic, and I wanted to start with. I've got the intuitive approach pulled up here, but I wanted to start actually before jumping into that back here at our heights and kind of talk a little bit about what this is about. So the way science works is if we want to know something, we try to go out, we measure it. And I would just want to start with the example of this height of women because in other contexts, I've used data before from this website. This is Wikipedia, and they have information about different studies that were done and the average heights of males and females um, and then what's useful and interesting is that they have information about the study and they tell you a little bit about the N, how many people were sampled. So um, if I want to know the average height of women in the US, just building off of our last video, how would I do that? And I think in the last class we all agreed, well, if we wanted to know something about the age of the dogs in Chicago, we can't go and get access to every single dog. It's just too crazy. So we do a sample. And that's exactly what happened here. And so what I did is I went from here to this link. And I've already got that link pulled up. So I'm going to pull that down here. And then I scrolled down into the methodology and was, reading about how they did it. And so you can see here that they basically drove little mobile examination centers around and measured things about people's bodies. Not everybody agreed to do that. You can see that the response rate was 60%, 50%. So, kind of depended on I don't know, you show up in a van and you're like, I want to measure your body from the government. Is that a good thing, a bad thing? So not everybody agreed to do it. And although this part says the report is based on 18,000 people, the Wikipedia report says that there's only 5,000 females. I suspect that if we dig deeper into the results, we would see confirmation. I'm trusting Wikipedia is accurate here. I guess we could dive into that a little deeper. But so the end result of that work, according to Wikipedia, is that the average height for women is 5'3.5" and that's representative of the population, right? We're saying we think this is the average of the population only based on 5,000 women. I'm now kind of curious. I said all those words. If I go and find the height data, height in inches for adult females. This is table 14. All race and origins. So this is just everybody 20 and over. There we go, 5,510. That's exactly what it says in Wikipedia. And the 50th percentile, 63.5, which is actually the same as the mean. So the median and the mean are the same, could be normally distributed. So, there's a lot that goes into, is this the right answer, right? We don't know for sure because we haven't lined up every single woman in the United States and said, tell me your height, or let me measure you. So one of the things that happens is that scientists go out and do work and then they publish it and they're like, okay, these are the results, is what we think the situation is. And then other people do other work and they come back with a different answer. And then they have to decide, like, is this right? Is this a weird response? And I'm thinking more about like situations where I'm trying an intervention and I want to see if there's something different about the way people responded based on my intervention. And so this is where hypothesis testing comes into play. So the basic idea is I have an idea of what I think the answer is based on previous research. I go out and I conduct a new study. I collect information. And then based on my work, I see if my answer to the same question is strange enough, weird enough to say that I think this result shows there's something wrong with the original assumption or what we believed about the world before. And that's the process of hypothesis testing. So the example that I've got in the Excel file here is that we've got a coin, and the assumption is that it's a fair coin, which means it's a 50% chance of coming up heads or coming up tails. And what I did is I just constructed using Combin, which is combinations, how many different ways could I flip 100 coins and end up with 3 heads. Already by the time you're looking at 3 heads, it's a massive number. By the time we get into the more likely combinations in the middle, this is times 10 to the 29th. There's a lot of different ways that I could flip 100 coins or one coin 100 times and end up with 50 heads and 50 tails. This is the most likely outcome. And if I turn this into a percent, so I can kind of see what that is more easily, that's about 8% of the time I should end up with exactly 50-50. What's interesting, of course, is that mentally we think 50-50 is the most likely outcome, and it is, but it is really, compared to all the other outcomes, there's a 92% chance that it's not going to be 50-50. So one of the things that we want to explore in this intuitive sheet is, like, what happens if we get, let me bring back all my decimals here. What happens if we get 51 heads? Is that like a weird outcome? Would we be surprised? Would we start thinking, oh my God, there's something wrong with my coin? So that's the first question that I would want you to answer. And I don't need you to do the experiment. We've done the experiment on a smaller level with the 10 coins. And we saw that although we might think 5 is the most likely outcome, well, it is the most likely outcome, but in fact, all the other outcomes added together are more likely than 5. And we saw when we did the actual testing experimentally that, we got a lot of other results. In fact, somebody got like 8 heads or 9 heads or something like that. So crazy. So this first question, just going on your gut, going on what you understand, what can we say about getting 51 heads? So the next part, we're going to do a little bit of math. So let's look at 60 heads. What percentage of the time do we expect to get 60 or more heads? So method 1, I would say, let's just use the probabilities provided and add up all the probabilities from 60 and up. So of course, method I'm thinking of here is sum. I can just use the sum formula to go and add up all the probabilities from 60 down. I need to be able to see this, but basically from here down, I want to add all these numbers up. I would not use a calculator. I'm going to use Excel to do that. You can use the sum formula. I know you know how to do that. Now, what could we use for our second method? Well, notice that this distribution is very normal. And so we could just do a little bit of work using our mean and standard deviation to figure out the z-score using 60 as our data point with the mean and standard deviation, and then translate that z-score into a probability. Now remember that back in M6, we showed that there was actually another way to do this where you don't have to go through the z-score. But again, given all the work we've done with z-scores, I think that's a relatively good thing. Now, these answers are not going to match. They're not going to be exactly the same, but they should be similar. I'm going to pause here and do it and then see what we come up with. Okay, so I've done the work and I've found 2.8%, 2.3%. These are close answers, not exactly the same. And again, it's because we're kind of approaching this in slightly different ways. And the normal distribution is not actually the same as the binomial distribution. That's another reason that we might be getting a slightly different answer. But these are close, and that makes me feel good about the fact that I have two methods that are working right. And they both make sense to me, which is, look, 60 heads, you're starting to get into a range where it's like, and this is actually the answer to this question. You're starting to get into a range where it's like, is that a weird result? I mean, I'm okay with not getting 50, 51, 49, 53. Fine. That's pretty normal. If we get 60, it's like starting to get significantly more heads than tails. It's a 20 flip difference between how many heads and tails you got. And so I'm starting to maybe ask questions about whether my coin is actually fair. So this is an opinion question, and you can have feelings about it one way or the other. And then I'm going to ask you to go up to 70 and answer the same question. Now, there's no math involved in this question. So for this one and this one, you're just kind of talking about your opinion. In this one, I would try to bring in something about the percentages that we calculated, because you have the evidence right there. And it's always good practice to bring in percentages as you're talking about it. So remember that the percentages represent the likelihood, right? 0% means absolutely not happening. 100% means it's definitely happening. 50% equally likely to happen or not. Okay. So that's the intuitive approach and kind of an explanation of what hypothesis testing is. I'm going to stop there, and then we're going to actually do the hypothesis testing steps.